This is a video from section 3.11. Sinh x is equal to e to the x minus e to the negative x divided by 2. Now, I want to differentiate both sides with respect to x. So the derivative of sinh x with respect to x is the same as the derivative of e to the x minus e to the negative x divided by 2 with respect to x. So I'm going to pull a 1/2 out in front, and I get 1/2 the derivative of e to the x minus e to the negative x with respect to x. And so this is 1/2 the quantity. Now, the derivative of e to the x is e to the x minus the derivative of e to the negative x with respect to x is e to the negative x times -1. So that's just chain rule. And so this is equal to 1/2 of e to the x plus e to the negative x. But if you don't mind, I'm going to rewrite this as e to the x plus e to the negative x divided by 2. And we should recognize this as cosh x. And so therefore, the derivative of sinh x with respect to x is equal to cosh x. And we can do the same thing when we want to find the derivative of cosh x with respect to x. And so cosh x is e to the x plus e to the negative x divided by 2. And I'm going to differentiate both sides with respect to x. So the derivative of cosh x with respect to x is the same as the derivative of e to the x plus e to the negative x divided by 2 with respect to x. And so I'm going to pull the 1/2 out in front and get 1/2 the derivative of e to the x plus e to the negative x with respect to x. And so this is 1/2 the quantity. The derivative of e to the x is e to the x. And again, this is with respect to x. Plus the derivative of e to the negative x with respect to x is e to the negative x times -1. Again, that's just chain rule. And so this is 1/2 of e to the x minus e to the negative x. And if you don't mind, I'm going to write this as e to the x minus e to the negative x divided by 2. And that's equal to sinh x, which is what we wanted. And so therefore, the derivative of cosh x, again with respect to x, I can't stress that enough, this is equal to sinh x. If we look at hyperbolic tangent x, this is the same as sinh x divided by cosh x. And I'm going to take the derivative of both sides with respect to x. So the derivative of hyperbolic tangent x with respect to x is the same as the derivative of sinh x over cosh x with respect to x. But I have to do the quotient rule here. And we've already derived the derivative for both cosh x and sinh x, so why not use it? So I'm going to write down the bottom function, and I'm going to multiply by the derivative of the top function, which is cosh x, right, minus the top function is sinh x, times the derivative of the bottom function with respect to x, which again is sinh x, and I'm going to take that whole amount and I'm going to divide by cosh squared x. So this is cosh squared x minus sinh squared x divided by cosh squared x. But remember, cosh squared x minus sinh squared x equals 1. And so this is 1 over cosh squared x, which is hyperbolic secant squared x. And we can now say that the derivative of hyperbolic tangent x is equal to hyperbolic secant squared x. And that's how we derive that one. Now, hyperbolic cosecant x is the same as 1 divided by sinh x. Okay? So when I take the derivative of both sides, I get the derivative of hyperbolic cosecant x is the same as the derivative of 1 over sinh x. But this is, by the chain rule, negative 1 over sinh squared x times the derivative of sinh x. So sinh x is my inside function. So I have to multiply it by cosh x. But this is negative 1 over sinh x. So I'm going to do a tiny bit of manipulation here. And I'm going to multiply by cosh x divided by sinh x. So you notice how these two lines match up exactly. I just rewrote the third line in a different way. And so this is negative hyperbolic cosecant x times hyperbolic cotangent x. And we can now say that the derivative of hyperbolic cosecant x is the same as negative hyperbolic cosecant x times hyperbolic cotangent x. And so that's how that one works. If we look at hyperbolic secant x, this is 1 over cosh x. And so I'm going to differentiate both sides with respect to x. So the derivative of hyperbolic secant x with respect to x is the same as the derivative of 1 over cosh x with respect to x. But this is negative 1 over cosh squared x. So this is again chain rule. And then I have to multiply by the derivative of cosh x. That's my inside function again. And the derivative of cosh x is sinh x. And so I have to write this in a slightly different way. And so this is negative 1 over cosh x times sinh x over cosh x. So again, these two lines match, but the third line allows me to simplify a little bit easier. And so here I get negative hyperbolic secant x times hyperbolic tangent x. So therefore, the derivative of hyperbolic secant x is the same as negative hyperbolic secant x times hyperbolic tangent x. And we have one more here, I believe. So we did, if you notice, we did hyperbolic cosecant x, right? And we did hyperbolic secant x. And so the last one I want to cover is hyperbolic cotangent x. And so this is cosh x over sinh x. This one's a little bit cleaner to do the quotient rule. And so if I take the derivative of hyperbolic cotangent x, this is the same as the derivative of cosh x over sinh x, right? And so this is sinh x, right? That's the bottom function. And then the derivative of the top function is sinh x minus the top function, which is cosh x, times the derivative of the bottom function, which again is cosh x, and I'm going to divide by sinh squared x. But this is sinh squared x minus cosh squared x divided by sinh squared x. And I'm going to factor out a negative 1 out of the numerator there. And so I'm going to get negative 1 times cosh squared x minus sinh squared x divided by sinh squared x. But remember that cosh squared x minus sinh squared x is 1. And so this is negative 1 times 1 divided by sinh squared x. So again, remember, cosh squared x minus sinh squared x equals 1. And so this is negative hyperbolic cosecant squared x. And we can thus say that the derivative of hyperbolic cotangent x is the same as negative hyperbolic cosecant squared x. And so I wanted to derive the derivative of all 6 hyperbolic trigonometric functions. Now, with that, I want to look at some examples. It says, find the derivative and we're going to simplify where possible. Okay? And with that, we're going to take a look at 35. So on 35, we have f of x is equal to cosh 3x. And I want to find f prime of x. Now, the inside function is 3x. So you can say h of x is 3x. The outside function is, we can call it r of x is equal to cosh x. And remember that the derivative of the cosh function is the sinh function. So, and we have to evaluate at the inside function, that 3x. So in other words, we're going to get sinh of 3x. But remember, we have to multiply by the derivative of the inside function. So that's the peeling the onion part. So we're going to multiply by the derivative of 3x with respect to x. And so the derivative of 3x is 3. And so I'm going to get 3 times sinh of 3x. And so therefore, f prime of x is 3 times sinh of 3x. So think about peeling the onion. You're working outside to inside. That's 35. If we take a look at 36, we have f of x is equal to e to the x times cosh x. And I want f prime of x. So this is classic product rule. So I'm going to write down the first function, which is e to the x, and I'm going to multiply by the derivative of the second function. The derivative of cosh x is sinh x. And then I'm going to go plus cosh x, right? That's the second function, times the derivative of the first function, which is e to the x. So I'm going to do something with you guys because we need to be able to simplify this, okay? It's very important. I'm going to factor out that e to the x. And if you notice, I get sinh x plus cosh x, okay? Now, there's an identity that you learned early on that sinh x plus cosh x is equal to e to the x. But let's say we don't remember that, okay? What you can do is go back to the definition. And so I would write e to the x times the quantity, e to the x minus e to the negative x divided by 2, plus, and then cosh x is e to the x plus e to the negative x divided by 2. And you have the same denominator, so you could add the numerators. And so this is e to the x times the quantity, e to the x minus e to the negative x plus e to the x plus e to the negative x, all divided by 2. But these middle terms cancel, and you get e to the x times 2, oh, excuse me. Let's back up. So let's write these last two terms. So it's actually the second term and fourth term cancel. And so what we end up getting is 2e to the x divided by 2. 2's cancel, and we get e to the 2x. And so therefore, f prime of x is equal to e to the 2x. And that would be considered simplified. 37. Suppose h of x is equal to sinh of x squared. If I want h prime of x, you're going to get cosh evaluated at x squared. But remember, you're dealing with the chain rule. So you have to multiply by the derivative of x squared with respect to x. But the derivative of x squared is 2x. So this is 2x cosh of x squared. And so therefore, h prime of x is 2x cosh of x squared. That's 37. 38. So suppose g of x is, if you don't mind, I'm going to write this as sinh x to the second. So this is very different than problem 37. Now this time my inside function is sinh x. Last time my inside function was x squared. So we want to be mindful of that. So when I take the derivative, I get 2 times sinh x to the first. So you think power rule, but remember we have to multiply by the derivative of the inside function, which in this case is sinh x. So I'm peeling the onion. So this is 2 sinh x cosh x. But we learned an identity. And in that identity, we have proven that sinh 2x is the same as 2 sinh x cosh x. So we could actually write this as sinh evaluated, or I'll say of 2x. And so therefore, g prime of x is equal to sinh of 2x. That's 38. 39. Suppose g of t is equal to sinh of natural log of t. And so I want g prime of t. So that's going to be cosh evaluated at natural log of t, or cosh of natural log of t, times the derivative of natural log of t with respect to t. So this is cosh of natural log of t, and I'm going to multiply it by 1 over t. And so this is e to the natural log of t plus e to the negative natural log of t divided by 2, and I'm going to multiply by 1 over t. Okay, so we're going to do a little bit of simplifying here. So this is t plus e to the natural log of t raised to the negative 1 divided by 2t, okay, which is equal to t plus t to the negative 1 divided by 2t. Now multiply numerator and denominator by t, and I want you to notice what happens. So t times t is t squared, right? T to the negative 1 times t is 1. So notice t to the negative 1 times t is 1 over t times t. T's cancel, you get 1. And again, of course, t can't be 0. And then I'm going to divide by 2t squared. And so therefore, g prime of t is t squared plus 1 divided by 2t squared. And I want to take a look at 40. So on problem 40, we have f of t. Again, very subtle, but now we're taking natural log of sinh t. And so when I want f prime of t, you're going to get a completely different answer than 39, because now my outside function is the natural log function. My inside function is sinh t. And so here I get 1 over the inside function. But I have to multiply by the chain rule, by the derivative of sinh t with respect to t. And so this is 1 over sinh t times cosh t, right? And so this is cosh t divided by sinh t, which is hyperbolic cotangent t. And so therefore, f prime of t is hyperbolic cotangent t. And that's problem number 40. I want to take a look at problem 41. Suppose f of x is hyperbolic tangent of square root of x, and I want f prime of x. Okay. Now, this is hyperbolic secant squared of square root of x times the derivative of square root of x with respect to x. And so this is hyperbolic secant squared of square root of x times, now, by the way, square root of x is the same as x to the half. So imagine we're taking the derivative of x to the half with respect to x, and that's 1/2 x to the negative a half. So that's just power rule, right? Okay, and then here I get hyperbolic secant squared of square root of x divided by 2 square root of x. And so therefore, f prime of x is hyperbolic secant squared of square root of x divided by 2 times the square root of x. And that's a good stopping point for this video. That'll conclude this video for section 3.11. And we did problems 35 through 41, all of them. And we also, we derived the derivatives of all 6 hyperbolic trigonometric functions. Thank you.